So we're taking a look at transforming equations. This is 4-7. And we have some equations that we need to solve for a different variable. Now, the first thing that seems to trip people up is when we have this semicolon. This semicolon does not have mathematical value. It is just a separator. We have an equation here, and this is the variable you're trying to get by itself. This piece here is not part of the equation. And that can be said for this problem and this problem as well. Let's get started. We have s is equal to g times t squared, and we want g by itself. So what's the opposite of multiplying g by t squared? Dividing g by t squared. So let's go ahead and divide both sides by t squared. I'm going to put my little separating train tracks there. And so we get s over t squared is equal to g. And that's it. That's a simple one-step problem. Not too bad, really. For question 10, we have the amount is equal to the principal plus the principal times the rate times the time. And we want the rate by itself. Well, what's the opposite of multiplying r by p and t? Dividing r by p and t. But wait a second, we still have this plus 1 here. So we need to deal with that first because we are going in reverse, please excuse my dear Aunt Sally order. So really the first question you need to ask yourself is, what is the opposite of adding p? Well, of course it's subtracting p, so let's subtract p from both sides. I can't take p away from a, so I just have a minus p is equal to p r t. Now we get into what's the opposite of multiplying r by p and t? Dividing it by p and t. So what I do to one side, I must do to the other. So p divided by p is 1, so it cancels out. T divided by t is also 1. And so we are just left with r is equal to a minus p over pt. Again, that one wasn't too bad either. Let's look at number 27. Before I do that, I'm going to move this problem, maybe, over here, so I have a little extra room to work. Now, we are trying to get the a all by itself. And right now, I am dividing everything over here by 2. What's the opposite of dividing by 2? That's right, it is multiplying by 2. So I'm going to multiply this whole piece by 2. Well, if I multiply this whole piece by 2, I must multiply this by 2 as well. So I end up with 2d is equal to, well, 2 divided by 2 is 1. So we get a times 2t minus 1. Well, what's the opposite of multiplying a by 2t minus 1? Dividing a by 2t minus 1. And what I do to one side, I must do to the other. And you'll probably know that 2t minus 1 divided by 2t minus 1, well, they cancel out, right? So I just am left with a is equal to 2d over 2t minus 1. I do want to take a little tangent and take a look at this problem, which is a review problem. I have a monomial taken to a power, and then I have this monomial right next to this monomial, which means we're multiplying these two together. And we're being asked to simplify it. Well, if I look at, please excuse my dear Aunt Sally, understanding that those are equal, I see that I must deal with my exponents first. So that means this monomial taken to a power must be simplified before I can do any multiplication. So that's 1, this is 2. So 2 to the third is 2 times 2 times 2, which is 8. A squared to the third is going to be a to the, and we multiply the exponents, 6th. And so let's rewrite everything that I have not done so far. So now it's time to multiply the monomials. And when we multiply monomials, that means the exponents for the bases that are the same will be added. So we have 3 times 8, which is 24. A to the 6th times a to the third is going to be a to the 9th because we are adding the exponents. And I don't have any b's here, so I'm just left with b squared. And there's my answer. So quick little review mixed into that one. But before we go, I would like to take a look at a previous problem that you have already seen in class. And, oh, there we go, okay. I want to go through this one because I'm thinking that we're having some confusion on the whole fraction thing. So I'm going to go through it one more time. So again, we're going to have our train tracks, and we're trying to get this n by itself. Well, what's the opposite of adding a? Subtracting a. So I'm going to subtract a from both sides. So I have L minus a is equal to n minus 1 times d. What's the opposite of multiplying this whole binomial by d? Dividing by d. So I'll divide everything by d. And d divided by d cancels out. So I'm left with n minus 1 is equal to L minus a over d. And you'll notice how I've dropped the parentheses because there's no more need for them, because this d was originally being multiplied or distributed to everything in the term. But once we've gotten rid of this d by dividing both sides by d, the parentheses become unnecessary. So now, what's the opposite of subtracting n by 1? Adding 1. And so we end up with n is equal to L minus a over d plus 1. But this just doesn't look right. This is not simplified because you can't add a fraction with the denominator of d to 1. So we need a common denominator. What's the common denominator? Well, there's only one thing in the denominator, so obviously it has to be d. So what I'm going to do is I'm going to multiply, do this in a different color, I'm going to multiply 1 by d over d, because then I have common denominators. Well, d over d times 1 is just d over d. So that means I have L minus a over d plus d over d. Well, now I can add these things because I have a common denominator. So I end up with L minus a plus my d over d is equal to n. And that is the correct answer. I hope that was helpful on your journey through transforming equations.